So let's go to the next one that comes from Dikomu, DK. Let's say hello, DK. Hello. Thank you for sending this question. I hope it's also going to help someone. It's the same as one of the things we did talk about. It says two circles have the following equations. They gave us the equations of two circles. And then they say we need to, number one, find the centers and the radius of each. And number two, we need to find the distance between the two centers and state whether the circles touch, they don't touch, or they cross each other. Very important. State whether the circles intersect, give a reason for your answer. Okay, cool. So let's have fun. Let's have fun. First one, circle number one. I'm going to call it circle A. Let's call it circle A. It was not mentioned on the question. It has the equation x squared. If you haven't seen completing the square, or you were still not as confident as I want you to be, I hope this is also going to help you. Plus 4x minus 6y minus 3 is equals to 0. Okay, let's say that. Thank you for sending this question, DK. Right, DK. Right, okay, fine. So I want to find the center and the radius of this circle. Okay, for me to do that, I obviously need to complete the square. X squared plus y squared plus 4x minus 6y minus 3 equals to 0. What do? You just group all the x's together. I'm going to have 4x there. And then you group all the y's together. I'm going to have y squared minus 6y. And you chase 3 by adding 3 on both sides, or doing witchcraft mathematics, taking the 3 to the right is going to be positive. Right. Now, after doing that, you're just looking for half. You just target the middle term as far as, the x term, as far as x is concerned. I'm interested in this. I'm looking for half. Half of who? Half of this with its sign. You want half of 4, which is 2. You squared it. That's all you do when you're completing the square. So I've got x squared plus 4x. I'm adding half of 4, which is 2. So I'm adding plus 2 squared. If I add it on the left, I need to also add it on the right. What you do on the left, you do on the right. This is the law of conservation of mathematics. Okay, for the y's, let's go to the y's. The y's have got y squared. They also have minus 6y. I'm adding. What am I adding? Half of the middle term. Half of that y term, this one, with its sign. That's the keyword. Half of minus 6. So I'm looking for half of, not 6, but negative 6. So half of negative 6 is negative 3. What do I tell my kids? I tell them, do not work out negative 6 squared. Leave it at negative 3 squared, because half of 6 is 3. Right, we're going to add it also on the right-hand side. I just tell them, don't work it out to 9. Don't work 2 squared to 4. Leave them the way they are. Why? Because when you're completing the square for the axis, you take the term from the square, and you take the term from the square, you make a square. Take a square, and a square, you make a square with its sign. For the y's, I'm going to do the same thing. I've got y squared and minus 3. So I take the term from a square, I take a term from the square, and I make a square. This is the shortcut of factorizing y squared minus 6y plus 9. It's me trying to actually do it differently in a way that is a bit quicker. Okay, now on the right-hand side, I just have numbers. So I'm adding, what is 3 plus 2 squared, which is 4, plus 3 squared, which is 9. We could have done this without a calculator. We're ending up with 3 plus 4 plus 9, which is 16. And we're happy to see that, because 16 is a perfect square. It means the radius is going to be nice. What does that mean then? That means that the center, right, of this circle, right, is going to be negative 2 and positive 3 is radius, right? The radius of this is not going to be 16. What you're looking at there is r squared, not r. So you have to take the square root of that, beautiful people. If r squared is 16, then r is going to be the square root of that, which is supposed to be 4. So the radius is going to be 4. That's as far as circle A is concerned. We've got its center, and we also have its radius. Right. Now let's go to the second circle. Circle number 2, not center B. Right. Circle B. I'm just calling it circle B. It was not told, specified in this question. So we can name it whatever you want to name it, but the examiner needs to see if you introduce stuff, because they're going to be looking at your work when they're marking you with the marking center. So any new thing that is not on the question paper that you introduce needs to always appear on the diagram. If you're solving something, you feel like you want to introduce a point A that is going to help you to find an answer, but it was not on the original question, let them know. Just say, let's insert point A. Then you put point A there. When they look at the diagram, they must see A. You can't talk about A in your answer sheet and I look at the diagram. I don't see A anywhere. I'm going to mark you wrong, everything wrong, because I don't know what you're talking about. So always specify what you're talking about and put on a diagram so that people can see where this thing that you're talking about is appearing on your diagram. Right. So circle center B, its equation was given to us as x squared plus y squared minus 8x. Add that to 2y, so x squared plus y squared minus 8x plus 2y minus 4. The answer is to be equal to 0. So beautiful people, you also know how to complete the square. I've got x squared. I need to bring minus 8 closer. So that's why minus 8x is going to be here. And we need to add half of that squared, right? For the y's, I've got y squared. I have 2y. I need to add half of 2 squared. But what you do on the left, you also need to do on the right hand side. Remember, there was a 4. Like I always say, this one needs to go. You do what we call witchcraft mathematics. You take 4 to the right hand side, things jump, things, and then they suddenly change signs. So it's minus 4, it goes outside, it's going to be plus 4. And we need to add, of course, something squared and also add something else squared. What are those things that we are adding? Well, we are adding half of minus 8, which is minus 4. So I'm going to add minus 4 here, squared. Half of plus 2, which is plus 1 squared. Because we added them on the left, we need to also add them on the right hand side. No complications. Completing the square. Very simple. Beautiful stuff. Okay, cool. So now on the axis, like I said, you don't have to work out 4 squared to 16. You complete the square by taking a square and a square to make a square. For the y's, you take a square term and a square term to make a square. And then whatever you have on the right hand side, you just work that out with your calculator. You won't have any problems. It is 4 added with 4 squared, that is 16, added with 1. And we're ending up with 21. Not so nice because it is not a perfect square. But then it's not a train smash. We can work with 21. So that's 16 plus 4, which is 20 plus 1. You didn't need a calculator. On that one as well, your answer comes out as 21. Like, we didn't make any mistake on this. Yes, it's coming out pretty well. X minus 4 and y plus 1. So the center of the new circle is going to be 4 and negative 1. And the radius of this is not 21, but the square root of 21 for reasons that we have explained already. Right. So this is the story as far as answering the first part of the question was concerned. The second part was asking us to find the distance between the two centers and state whether these two centers, these two circles, will intersect each other or not. Okay, cool. Okay, no problem. Okay, this is actually the story. The first circle has a center at negative 2 and 3. All right, it has a center at negative 2 and 3 with a radius of how much? With a radius of 4. Negative 2 plus 3, radius is 4, right? With a radius of 4. Okay, the second circle has a radius of square root 21. We are looking at it, but its center, which I'm going to call B, is 4 and negative 1. So they want the distance between the centers. So that means we are looking for the length of AB, which is going to be the square root of x at the first one minus x at the second one. So x of b minus x of a squared plus y of b minus y of a squared. This is in the formula sheet. It's written as x2 minus x1, y2 minus y1. You don't have to write it down. You can just go straight to the answers. But I'm doing it for the benefit of your education. So x2 is 4 minus 2. That's going to be plus 2 squared. And for the y's, I've got minus 1 minus 3, okay, with a square, right? And the answer to this is going to be 6 squared, which is 36. Add that to 4 squared, which is 16. Yes, it's 16. Yes, it's 4 squared, which is 16. If you sum those up, it's actually 52, right? 2, 3, 4, 5. So it's actually 52, not 55. Right, so the answer is going to be the square root of 52. Now you can take your calculator, of course, and confirm that you're not making any mistake. When you do indeed add the 36 with 4 squared, which is 16, you do get 52. When you take the square root of that answer, you end up with 2 square root 13, right? You end up with 2 square root 13. So let's go back and write it down as 2 square root 13. Now what I want to encourage you to do is just next to this, write the answer in decimal form if nobody told you how to express your answer. So I'm going to go back to my calculator and ask it, what is 2 root 13 in decimal form if I'm writing it to 2 decimal places? Now I'm getting 7.21. Okay, so the answer is 7.21 if I'm converting this to 2 decimal places. This is important because I need to work out the actual distance between the 2 radii as well as the 2 centers of the circles. So according to this story, we know now the length between the 2 centers of the circles is 7.21. But are these circles intersecting each other or are they not intersecting each other? If I've got a circle here, which is the yellow circle, and I've got the white circle here, I want to know this one is the one centered at A, this one is the one centered at B. Do these 2 circles touch each other or they don't touch each other? The key is on finding the sum of the radii versus the distance between the centers. So this is big R, this one is small r. And the distance between the centers of these two is this length AB. Obviously, if the length AB is bigger than the sum of the radii, then they don't touch. But if I make them to touch each other, if they touch each other, what is going to happen? If these two circles touch each other, this is the circle A, this one is the circle B, right? Then you'll notice that the distance you get when you sum the radius of the first one and the radius of the second one is going to be the same as the distance you get when you look for the length of AB. But if they're not going to be like that, such that they actually cross each other or they intersect each other, you will agree with me that the first circle, which is centered at A, and the second circle centered at B, the distance between the centers is smaller than the sum of the radii. Then this means they're going to definitely touch each other. In fact, they're going to intersect each other if this happens. So that's the story with the whole concept of whether circles intersect each other or not. If I start with AB, if the distance between the centers is bigger than the sum of the radii, then they don't intersect, don't touch. They don't touch, they don't intersect, right? Okay, don't touch, don't intersect. You can even say don't intersect. These ones, such that AB, the length of the distance you get between the centers, is equal to the sum of the radii, then this would mean that they touch. They do touch externally. But if you have a situation where the length of the distance between the centers is smaller than the sum of the radii, then these ones, they definitely intersect. So our story is just to see which one of these three cases is applicable in the question that we're dealing with. Which one of these three cases is the one that we're actually dealing with? Then from that, we can be able to then tell people whether they touch or they don't touch, or whether they intersect as well. So let's find the sum of the radii versus what we just calculated. So if I work out the sum of the radii, one radius plus the other radius we are getting, the other one give us a radius of 4, the other one give us a radius of square root 21. That's what we got from the top. One radius is 4, one radius is 21, square root of 21. So when you sum that up, what do you end up with? What do you end up with? Well, you'll end up with 4 added with the square root of 21, and then the answer is 4 plus square root of 21, which in decimal forms is 8,58. So we're getting 8,58. And then which one of these two conditions are we actually getting from this? If the sum of the radii is giving us 8.58, AB ended up with 7,21, right? So I'm actually comparing. This is the length of AB, don't forget that, right? And the other one is the sum of the radii. The other one is R plus R. We ended up with 8.58. So which one is bigger? Tell me, which one is bigger? Is 7,21 equal to 8,58? Obviously not. So which one is bigger? Clearly, 7,21 is smaller than 8.58. Which one of those three conditions are we ending up with? Well, we are ending up with the one that says if the distance between the centers is smaller than the sum of the radii, then it means that these two circles intersect each other. So where are we? We are here. This is where the story is. We are definitely here. This is actually what the story is going to be. So you're then going to say they intersect each other because the distance between the centers is smaller than the sum of the radii. Right? Therefore, they intersect because, let's write the mathematics symbol for because. We want you to learn they intersect because, oh, my thought. The distance, we are answering the question now, right? The distance between the centers is smaller than the sum, right, of the radii. People say radii, it's radii, right? This is actually the story. It's actually smaller than the sum of the radii, and this will be the solution to this problem.